multiply a binomial by itself many times. There are another method like FOIL, but that would take a very long time, right? But then with the binomial theorem, you will be figuring out the answer faster. Next. And this is the formula for the binomial theorem. Next. Okay, so first, a binomial is a polynomial with two terms. For example, 5y cubed minus 3. This is one polynomial and this is another polynomial makes up a binomial. Okay, next. Okay, so the theorem shows what happens when you multiply a binomial by itself as many times as you want. It works because there is a pattern. That's amazing, right? So pause for a moment to appreciate how remarkable it is. Pattern. Next. So first, the exponent of 0. So it's a plus b to the power of 0, which is 1, right? And then for the exponent of 1, it's a plus b to the power of 1, which is itself is unchanged. And the third one is exponent of 2, a plus b squared. So it's a plus b times a plus b makes up a squared plus 2ab plus b squared. And lastly, exponent of 3, a plus b cubed. It's a plus b times a squared plus 2ab plus b squared. From this, then we end up with a cubed plus 3a squared b plus 3ab squared and plus b cubed. Okay, so the pattern. As you can see, for the exponents of 3, right? And then here we got a cubed plus 3a squared b plus 3ab squared plus b cubed. Exponents of a start at 3 and then it goes to 2, 1, and then 0. Here like 3, 2, 1, and 0. It means that this the exponents of a goes down, right? And for b, it starts at 0 and then goes on to 1, 2, and 3. 0, 1, 2, 3. So it goes up. You see a pattern?
Yes.
Thank you. So if we number the terms 0 to n, we get this. For k is equal to 0, we get for a cubed we get 1, and then k equal to 1, we get a squared and then b, right? And for k equals to 2, it's a and then b squared, and then for k equals to 3, it's 1 and b cubed. Brought together into the formula a to the power of n minus k times b to the power of k. I will justify this in the next slide. Next. Okay, if you are confused, let me show you the magic. Okay, so when the exponent n is 3, right, the terms are, so for k equals to 0, the formula we have here is a to the power of n minus k times b to the power of k, right? And then as you know, n is 3, right? And then k is 0, so n to the a to the power of 3 minus 0 times b to the power of 0, that makes up a cubed. And for k equal to 1, it's a to the power of 3 minus 1 times b to the power of 1, and that makes up a squared times b. And for k equals to 2, it's a to the power of 3 minus 2 and b squared, and that makes up a b squared. For the last one, it's k equals to 3, so that's a to the power of 3 minus 3 and then b to the power of 3, so it's b cubed. Okay, next. Okay, so far we have a cubed plus a squared b plus a b squared plus b cubed. But we really need a cubed plus 3a squared b plus 3ab squared plus b cubed, right? So what are we missing? We are missing the coefficients, which are the number in front, like 3 and 3 here. So let's look at all the results we got before. From since that previous slide, a plus b to the power of 0 up to a plus b to the power of 3. So for 0 we got 1, right? And for 1 we got a plus b. For 2 we got a squared plus 2ab plus b squared. And then for 3 we got a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, so far. Okay. Next. So, and now look at just the coefficients with the one where coefficient wasn't shown. So I make this part like bigger, so it's 1 and then 1 plus 1, right? 1 plus 2 plus 1, 1 plus 3 plus 3 plus 1. So as you know, this makes up a Pascal triangle. Okay?